All right, now we get to the complicated, convoluted stuff that is matrix addition, subtraction, and worst of all, multiplication. So for now, we're just going to ignore this board here because it's way easier to explain this stuff as we go through it. So we have these two matrices here, A and B, and then it asks us for first, number one, to do 2A minus B. So I'm going to take a different color. Let's do orange. Can you guys see the orange? Yes, you can. Cool. So first we need to do 2A minus B. So we're going to do 2 times A, which is 1, 2, negative 3, negative 1, minus B, which is 0, 1, 4, and 3. So how would we go about doing this first? Well, firstly, we have this here multiplication because our order of operations still applies with matrices. So when we have multiplying a constant by the whole thing, it says here, just multiply all the numbers by the constant. So we will have now 2, negative 6, 4, negative 2, minus 0, 1, 4, and 3. And now this next one, addition and subtraction, they must be the same dimensions. How do you figure out what dimensions matrix is? You go by the rows, by the columns. So the number of rows by the number of columns, this has 2 rows, this has 2 columns, this has 2 rows, this has 2 columns. So that means that this here is a 2 by 2, this here is a 2 by 2. So we can actually subtract this. And it wouldn't make sense to be able to do like a 3 by or a 4 by some that isn't the same thing as one another. It just wouldn't make sense because how it works is you just only do the operation on the corresponding numbers. So we would have 2 minus 0 is 2, negative 6 minus 4 is negative 10, 4 minus 1 is 3, negative 2 minus 3 is negative 5. So this would be the solution to number 1. If you notice, all I did was go from the corresponding numbers. So top left to top left, top right to top right, bottom left to bottom right. Bottom left to bottom left, bottom right to bottom right. Okay. Now we will solve number 2, BA. Now this is going to get convoluted and big, pretty big. So we are doing this problem here. 1, 2, negative 3, negative 1 times 0, 1, 4, 3. So how you do multiplication is your dimensions must match up properly. And what that means is we're dealing here with a 2 by 2 and a 2 by 2. So in order to do multiplication with this, the two numbers on the middle of the two multiplying, because it does matter which one goes first, because matrices will actually change. The multiplication will change if you have this one come first. So I just realized that if that's true, then I wrote them down in the wrong order because it has here BA. So 0, 1, 4, 3 times 1, 2, negative 3, negative 1. So we have here the 2 by 2, the 2 by 2. These two middle numbers must be equal in order for us to multiply. And then our solution, if these two are equal, our solution answer is going to be the outside numbers. So we're going to have a 2 by 2 answer. So, and these two must match up. And you'll see if they don't match up, it's impossible to do the math for it. So how this math works is we have to go row by row for the first one, column by column for the second one, row by row, column by column. So what we're going to do is make a big matrix so that we can do all the math. So we're going to go first row by row, and we're going to multiply them. So we're going to go this one times this one, then this one times this one. Yeah, that doesn't make too much sense. So we're going to go 0 times 1, 0 times 1 plus 4 times 2. So we're going row by row, column by column. Okay? Now our next one is going to be row by row, and then the other column by column. So 0 times -3, and this one I need to write over here, plus 4 times -3. Hope that you guys can see those small numbers. Yes, you can. Okay, and then now we will go the second row because we exhausted all of the ones here. Now you'll notice that if these two numbers did not match up, then we would have an extra number here and no more columns to go off of. So it wouldn't work. Or we would have exhausted up all of these numbers here and then had an extra column. And that wouldn't have worked either. Oh, actually, you know what? That actually would have worked. Because then you would just go one more column and you would just go 0 times 4 times other thing by other thing. So you would just do that nonsense. So now we would go 1 times 1 plus 1 times 2. And now for our next one, I want you to try to pause and see if you know what's coming next. I'll give you a little minute. And now if you've come back, 1 times -3 plus 3 times -1. 1 times -3 plus 3 times -1. Remember when I said it's going to get convoluted and big? That's the kind of convoluted and big we're dealing with here. So you would go again, row by column, row by column, row by column, row by column. So if you'll notice, we went row by column, row by column, row by column, row by column. So each of these things has their own two little dashes by it. So now we can just add all of that up. So 0 times 1 plus 4 times 2 is 8. So that there is -12. This here is 1 plus 2 is 3. This here is -3 plus -3 is -6. And this is our answer for the multiplication. Woo! I hate matrix algebra. It sucks, especially when you start getting the bigger numbers. So really quickly, let's just experiment for a minute and just show you how it would work if we had an extra column, just so that we can, or actually, you know what? We're going to do it a different way. We're going to go like this. We're going to have a 2 by 3 and a 3 by 3, and we're going to multiply those. So we're going to have, just for a little example so that we can see how it would work, we're going to have 1 and 2 and 2 and 1 and 3 and -1. So that would be a 2 by 3 times a 3 by 3, which would be 3 times 2 times 1, and then 2, 2, 1. And if you'll notice, I'm doing pretty small numbers here. 1, or -1, -2, 3. So let's think for a moment. These two numbers have to match up. Yes, they do. So our answer is going to be a 2 by 3. So a 2 by 3 means we will have 2 rows. Oh, actually, you know what? It's the number of rows by the number of columns. So I did this one wrong. This one has to be the other direction. This one will go 1, -2, 3, 2, -1, 2. So there we go. That's it now. Ah! My expo shot across the room. Okay. So now here, we will solve for it here. We have to go row by column, row by column, row by column, and then the other row by column, row by column, row by column. So big. Actually, you know what? Our answer is going to be a 2 by 3. So we're going to have this be kind of what it is. So we will have 1 times 3. Actually, you know what? I'm going to make this even bigger. So we're going to have If you can try to solve this one on your own, I would like you to, or at least solve the one that's on your paper, and probably why you looked up this video. So 1 times 3 plus, or it'd actually be minus, no, minus 2 times 2 plus, or minus 3 times 1. Whoa, big stuff, so I'm going to make this even larger. Okay, we will have 1 times 2 minus 2 times 2 minus 3 times 2. If you'll notice, I'm kind of swapping around these negatives to make it easier for me to do the math later on. And now we have this last column here, 1 times 1 minus 2 times 1 plus 3 times 3. Okay? Now we will go with our final one. We will go the second row, 2, 3, negative 1, 2, and then 2, 1, or negative 1. Then we will go 2, 2, minus 1, 2, minus 2, 2. Okay, now our final one, 2, 1, minus 1 times 1 plus 2, 3. So again, if you didn't see what I did there, I went number by number, row by row for these, and then column by column by column, then row, column by column by column. And then now we would just add all of that up. But really the hardest part is getting the setup for it all down. So I can erase this now. Woo, matrix algebra sucks. Okay, please reload yourself, computer. Now we have number 9, which is a nice break. Because number 9, I have it written here. Hopefully it's big enough so that you can read it. It's not. So what I'm going to do is, haha, oh, no, I don't have an idea. I'm going to do this, grab this, put this here, put this here. Haha, can you read that now? Yes, you can. I am so smart. Okay. So, a student is taking 4 courses, math, English, chemistry, and history, and spends 40 hours per week studying. The following facts are known about how the student allocates study time each week. The combined amount of study time for English and chemistry is the same as that for math and history. The amount of time spent on math is 1/4 the amount spent on the other 3 courses combined. Finally, the combined amount for English and history is 2/3 as much as that for math and chemistry. So, this is a set up the system problem. I don't really even want to solve this one. I just want to set up the system. So what we are first going to do is give everything a variable. What's very convenient is that all of these 4 classes have letters that all start with different things. So I would encourage you first to do this on your own, and then you come back to me once you think you either have it or are stuck. So we will have M stand for math, E stand for English, C stand for chemistry, H stand for history. So those are going to be our variables. So they're taking those 4 courses and they spend 40 hours per week studying, which means that if all of the amount of times are added up, it'll equal 40. So we're dealing with the amount of hours they're doing each of these subjects for. So that means each of these variables here will stand for hours per. And it's important to label what each of those means. So, or what your variables stand for in regards to those 4 courses. So what we have now is we know that M plus E plus C plus H equals 40. So math hours plus English hours plus chem hours plus history hours equals 40 hours. And that's our first piece of the puzzle done. So following facts are known. The combined amount of study time for English and chemistry is the same as that for math and history. So that means E plus C is equal to M plus H. So the amount of time spent on math is 1/4 spent on the other three combined. I need to make this set a little bit bigger. So is 1/4 the amount spent on all the other three courses combined. So that means that M over 4, or we can do 1/4 M, I like that a bit better, is equal to E plus C plus H. And then finally, the combined amount for English and history is 2/3 as much as that for math and chemistry. So that would be, I just realized that 1/4 the amount spent on the other three courses combined. This 1/4 has to be on the opposite side. Because that means that this is the one that's 1/4. So now the other one, so E plus H is equal to, E plus H is equal to 2/3 M plus C. And this would be our completed thing for that one. This would be our completed set. And then just a quick note about sets too. You'll know you have enough things to go off of based on how many variables you have. You will have 4 equations if you have 4 variables. You'll have 3 equations for 3 variables, 2 equations for 2 variables. You will have 5 equations for 5 variables, 6 for 6, so on. So we know that we have the proper amount here based on this. Right, I'm going to end the video now to make sure file sizes don't get big. Okay, now we have problem 12, which is just a solve these two, except obviously we can't use elimination here now because we've got some very complicated stuff going on. So we're not going to use elimination, and I'm instead going to use my orange again to try to solve for this. So first, let's get something that we can substitute for. This bottom equation is also equal to y is equal to 5 over 5, or x is equal to 5 over, no, y is equal to 5 over x. Let's say the things right, please. By dividing both sides by x, we can get that there. Substitute this answer in for the y up top. X squared is equal to 5 over, oh, it's not equal to, plus 5 over x squared is equal to 15. And then we can solve for our x. So we get x squared plus 25 over x squared is equal to 15. Multiply everything by x squared to get the variables out of the denominator. X to the 4th minus 15 x squared. I'm also going to put all the variables on one side in the same step. Plus 25 is equal to 0. Now this may look like a squares thing going on here, but it's not, because this number here doesn't allow it, because it has to follow that. I think the rule was like b divided by 2 squared is equal to c, something like that. It has to be that in order for it to work. So, or is equal to the root rather. So now we have to think of our solution for this. First of all, we're solving everything in x-fourths, so let's take x squared is equal to u, so that way we can solve for x squared. Now, or we can just ignore that entirely, because it would be easier to do the u if you don't understand how this would work, or we can just solve for the quadratic equation where it's all equal to x squared instead of x, because that's what we're solving for. So x squared is equal to 15 minus 15 minus the square, or plus or minus the square root of 15 squared minus 4 something times 25 all over 2. So let's plug this into our calculator. we have 15 plus this square root. So first of all, let's just see if this square root is a perfect square. 125. Perfect. That is a perfect square. Nope, it's not. Never mind. I lied. It just seemed like it was. So that would be rad 125. And that's just because I thought it was because 25 is, and I was like, oh, times 5 again. It's a perfect cube. It's not a perfect square. So we have x squared is equal to 15 plus or minus, we would go 5 rad 5, because that's the simplified version of rad 125. So 5 rad 5 over 2. And then we would all radical it again. X is equal to 15 plus or minus 5 rad 5 over 2, all under a radical again. That looks extremely ugly. So let's just try to simplify it a little bit more. X is equal to, let's just multiply everything by rad 2, 15, because we got to get radicals out of the denominator, 15 rad 2 plus or minus 5 rad 10 over 2. So now this here is our answer for x, and you would plug this in for the other answers to get y. So let's just try that right now. Y is equal to, so hold on, let's just make this easier for us. So y times 15 rad 2 plus or minus 5 rad 10 over 2 is equal to 5. Holy. So we will multiply by 2, 15y, or 15 rad 2y plus 5 rad 10y is equal to, actually, you know what, this is already simplified for us, so I'm not going to distribute that y over. We're just going to go y 15 rad 2 plus 5 rad 10 is equal to 10. Divide that over, y is equal to, and this is a plus or minus, so y is equal to 10 divided by 15 rad 2 plus or minus 5 rad 10. There you go. And now, one quick distinction I would like to make is if you use the pluses on the x, you have to use the pluses on the y for the things to check out. If you use the minus on the x, you have to use the minus. You can't swap them. You can't do the plus here and the minus there, or the minus here and the plus there. Otherwise, you will not get your answers right. They must be what you say they are. Okay. There we go with number 12. That one was a lot of complicated math, but still a breath of fresh air in comparison to the matrix algebra, in my opinion. And then our next problem says determine P and Q in parabola y equals px squared plus 2x minus 5, or plus qx minus 5, where our given in the problem ordered pairs that this parabola passes through are -2, -1, and -1, -2. So these here are our x values, these here are our y values, so we can substitute these numbers in for all of the stuff up there, which would leave us with just those two variables that we're trying to solve. So we can set up a system to try to solve for this. So we would go -1 is equal to, so -2 squared is 4p minus 2q minus 5, so we can add that over immediately to give us 4. And then our next one would be y, so -2, add that 5 over that we know that we're going to have to do later. So 3 is equal to px, so that is equal to p minus q, because we substitute in that y, or that x value. And then now we can simplify this bottom one, add that q over, we can have q plus 3 is equal to p. Substitute this whole thing in for the top equation. 4 is equal to 4 times q plus 3 minus 2q. 4 is equal to 4q plus 12 minus 2q. and then add everything together. Subtract that 12 over to give us negative 8 is equal to 2q. Q is equal to negative 4. So that's part of our answer. And now the other part of our answer would be solving to get p as well. So if q is equal to negative 4, let's plug it into this one. 3 is equal to p plus 4. Subtract that over. P is equal to negative 1. So our full equation is y is equal to negative x squared minus 4x minus 5. And then let's just test with my graphing calculator here if that does all check out. Negative x squared minus 4x minus 5. Go to graph. And then now let's calculate for when the value equals negative 2. Negative 2 equals negative 1, so that one checks out there. Let's calculate the value at negative 1 again. Negative 1, it equals negative 2 at that 1, which is perfectly what they gave us. Yay. And that is all of chapter 11. Also, a little behind the scenes, I had 5 takes for this problem. 5 takes. Because at first I didn't write the negative sign here, and then I realized that another point you can use is 0, negative 5, which was completely false because then that would just cancel out your P's and Q's. And then I had a lot of takes for that one. Because there were some where I just said dumb stuff, and then wasn't coherent, and just, I don't want to talk about it. I don't want to talk about it. Just go, leave, bye.